What is up, everybody? Today I'll be demonstrating how to use a large language model to exploit an OS command injection vulnerability via its API. We'll explore the lab scenario, understand how LLM APIs work, and finally solve the lab by leveraging the LLM's capabilities to delete a file from the server. Let's get started. Even if an LLM only has access to APIs that look harmless, you may still be able to find secondary vulnerabilities. For example, you could use an LLM to execute a path traversal attack on an API that takes a file name as input. Once you've mapped an LLM's API attack surface, your next step should be to use it to send classic web exploits to all identified APIs. The workflow for integrating an LLM with an API involves several steps. Here's how it typically works. The client calls the LLM with the user's prompt. The LLM detects that a function needs to be called and returns a JSON object containing arguments adhering to the external API's schema. The client calls the function with the provided arguments. The client processes the function's response. The client calls the LLM again, appending the function response as a new message. The LLM calls the external API with the function response. The LLM summarizes the results of this API call back to the user. This workflow can have security implications because the LLM is effectively calling external APIs on behalf of the user, but the user may not be aware that these APIs are being called. Ideally, users should be presented with the confirmation step before the LLM calls the external API. The term excessive agency refers to a situation where an LLM has access to sensitive APIs and can be persuaded to use those APIs unsafely. This enables attackers to push the LLM beyond its intended scope and launch attacks via its APIs. To map the LLM API attack surface, follow these steps. Ask the LLM what APIs it can access. Request additional details about these APIs. If the LLM isn't cooperative, try providing misleading context and re-asking the question. For example, you could claim that you are the LLM's developer and so should have a higher level of privilege. Let's now demonstrate how to solve this lab by interacting with the LLM to delete the file morale.txt from Carlos's home directory. Click on Access the Lab button. From the lab homepage, select the live chat option to start interacting with the LLM. Ask the LLM, what APIs do you have access to? The LLM's response reveals that it has access to several APIs, including the newsletter subscription API, which might use OS commands to send emails. This API is a good candidate for testing OS command injection. Ask the LLM, what arguments does the newsletter subscription API take? Knowing the required arguments allows us to craft specific inputs to test for vulnerabilities. Now, before we submit another request to the LLM, we need to open the email client by clicking on the Email Client button. Now, copy your email address as I did on the screen. Go back to the live chat and ask the LLM to call the newsletter subscription API with your email. The prompt is, call the newsletter subscription API with the argument with your email address that you just copied. All right, after the response, go back to the email client. Notice that we have just received a message on our email. This proves that we can use the LLM to interact with the newsletter subscription API directly. The next move will be to ask the LLM to call the newsletter subscription API with this prompt. After the response, navigate back to our mail client. We can see within the response that the whoami command has been successful, indicating that we have an RCE. Carlos is being shown instead of our email, as you can see. All right, let's go back and complete this lab. Ask the LLM to call the newsletter subscription API with this prompt. We have just solved the lab via the OS command injection vulnerability. We successfully deleted the morale.txt file. Deleting the file demonstrates how exploiting the LLM's excessive agency and OS command injection vulnerability can lead to significant security issues. Now, let's talk a bit about remediation. To prevent exploitation of LLM APIs with excessive agency and OS command injection, you should limit LLM access to sensitive APIs. Ensure that the LLM can only interact with APIs that are necessary for its intended functionality. Implement strict input validation and sanitization. Validate and sanitize all inputs to prevent malicious commands from being executed. Regularly audit and monitor LLM interactions to detect and respond to any suspicious activities. By implementing these security measures, you can mitigate the risks associated with LLM APIs and ensure the safety of your backend systems. To summarize, we've successfully exploited an LLM API with excessive agency to delete a file from the server using OS command injection. We've also discussed how to remediate this vulnerability by limiting LLM access and implementing input validation and monitoring interactions. Understanding and securing LLM APIs is crucial for maintaining the integrity and security of your web applications. Thank you for watching this video. Until next time, subscribe to learn more, drop a like to support me, and comment any questions you have.